11. The fourth term, which is equal to, which is A plus 3D, is also given as 32. The question now asks us to find the sum of the first 9 terms. So here, the formula for the sum of the first 9 terms is Sn, which is equal to n over 2 into 2a plus n minus 1d. This is the formula. Here, we are to determine the number of terms. The parameter we are going to be needing here is the first term, the number of terms, and the common difference. And since the question asks us to find the sum of the first 9 terms, automatically our n is 9. So we know our n, we know our a, then we are to calculate our d. So resulting to the information 2, which is this, we know that a plus 3d is equal to 32. From here, we know that our a is 11. So anywhere we see a, we replace it with 11. So 11 plus 3d gives 32. By collecting like terms, then we have 3d equals to 32 minus 11. So 3d then gives 21. So by dividing both sides by 3 to calculate our d, then we have this. So here our d then becomes 7. So we have succeeded in calculating our d. Now we have our a to be equals to 11. We have our d to be equals to 7. And we have our n to be equals to 9. Then we can now make use of this formula. Here we have s. Since we are dealing with number of times 9, then we have s9 will definitely be 9 over 2 into 2. What's our a? 11 plus, what's our n? 9 minus 1. What's our d? 7. So here we have succeeded in imputing all the known parameters. So we have s9 will now be 9 over 2. Then we try to evaluate this. This gives us 22 plus 8 times 7. We have 8 times 7, and 8 times 7 is 56. So you have 9 over 2 into 2 plus 56. 2 plus 56, S9, which is now 9 over 2. 22 plus 56 gives 78. So 2 here 1, 2 in 78, that is 3, 9. So we have S9 to be equal to 9 times 39, and that is 351. So our S9 is now 351. So the sum of the first 9 terms is 351. The next is geometric progression, known as GP. In the geometric progression, we have some important terms, just like the case for AP. We have our first term, which is equal to A. Our second term, which is equal to AR. And that can be deduced from our nth term, which is the last term. Our last term or the nth term, which is AR into raised to power n minus 1. So from here, our first term can be deduced. First term where n is equal to 1. So we have U1, which is AR 1 minus 1. And U1 will definitely be AR raised to power 0. And anything raised to power 0 is 1. That is where you have your U1 to be A. And that is our first term that is justified here. If you use n equals to 2 for the second time, you are still going to have this. So automatically our first term is A. Our second term will be AR. Our third term will be AR squared. Our fourth term will be AR cube. So that is the trend that we'll have. Then that is all about the UN. Then another important point is the sum. The sum, we have two sums. The first one, number 1, is when your R is greater than 1. When our R is greater than 1, the sum will definitely be A over R raised to power n minus 1 over R minus 1. So that is the formula when R is greater than 1. And 2, the second formula for the sum when R is less than 1. Then we have Sn to be equals to A into 1 minus R raised to power n over 1 minus R. That is when R is less than 1. Then we have another important term there. We call it sum to infinity. Sum to infinity, and it's always denoted by S infinity, which has a formula of A over 1 minus R. So these are the fundamental formulae for any operation on GP. Whether you are looking for the last term, or you are looking for the number of terms, or you are looking for the sum of terms, you have two sum of terms when R is greater than 1, when R is less than 1, and you also have sum to infinity. So these are the information that you need to survive as far as GP is concerned. Let's see some example to appreciate all the formulae that we have on the board. Example 1. Given the GP 5, 10, 20, you have example 1. We are given 5, 10, 20. 5, 10, 20, 40, 80. Sometimes the question might be technical by not mentioning that it is a GP. How do you know whether a particular sequence is in GP? Simply, you can know that by dividing the first term, dividing the second term by the first term. It must be equal to dividing the third term by the second term, and also the fourth term by the third term. This is the trend, and let's try and see whether this particular sequence is in GP. The second term here is 10 divided by 5 must be equals to 20 divided by 10, and must be equals to 40 divided by 20, must be equals to 80 divided by 40. So when we divide this, we have 2. 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 So therefore, with this operation performed on this sequence, it is justified that this sequence is in GP. Now the question now asks us to find its ninth, 47th, and the nth term. We have to look for the, based on this sequence, we know that our first term is 5, which is the first term here. Then our common ratio is 2. In GP we use common ratio. In AP we use common difference. Since the question asks us to look for the 9th term, which we incorporate UN, which is ARN minus 1. So we are talking about when n is 9, that's 9th term. Then we have U9 equals to AR 9 minus 1. So U9 will definitely be AR raised to power 8. What is our A? Our A is given as 5 and our R is given as 2. So we have U9 to be equals to A, which is 5, times 2 raised to power 8. And 2 raised to power 8 will definitely give us 64. 2 raised to the power 8 will definitely give us 64. 2 raised to the power 8. 2 raised to the power 8 will definitely give us 256. So we have 5 times 2 raised to the power 8, which is now 256. So 256 times 5 will be the result, and that is 1280. So U9 is 1280. And we can also leave the answer this way. It depends on the way the question is structured. So we have 256. So the second case, that is U47. That's when your n is equal to 47. Then we result into this again. So we have U47, which will now be AR47 minus 1. And that's U47 then becomes AR40 raised to the power 46. What is our A? Our A is 5 times, what is our R? Our R is 2 raised to the power 46. So we leave the answer this way. Then the last one, which is the nth term. So the nth term, UN, equals to AR raised to the power n minus 1. So UN, which now, what is our A? 5. What is our R? 2. So we have 2n minus 1. And this one can also be written as 5 times n over 2 raised to the power 1, which can be written as 5 over 2 times raised to the power n. So we can leave our answer this way or this way, depending on the way the question is structured. Find the sum of GP. 2 plus 6 plus 18 plus 54 plus dash dash dash. Then